Hello, this is Mrs. Pullen for AP Statistics Lesson 3.02. In this video, I'm going to show you how we quantify the strength of the relationship. So for example 1, I have 6 scatter plots. And what I'd like you to do is, based on the scatter plot and the R, the correlation coefficient, I want you to see if you can describe the relationship between the explanatory variable and the response variable, the y. So let's look at that scatter plot, and what do we notice? I'm going to do the first one with you. It looks somewhat strong and in a positive direction. So we would say it's a strong positive linear association. Put the video on hold and try for the remaining 5. Okay, we're back. So notice that for the second scatter plot, the points look like they form a line. They're not as strong as that first graph, but you definitely can see a line and they're in a moderate direction. So I would say that this is a moderately strong negative relationship. And notice the correlation coefficient when that happens. Let's look at this third scatter plot. This definitely seems like it's forming a line, a very strong line, a strong association, and it's in the negative direction. So this is a very strong negative relationship. And notice the correlation coefficient value. On the second row, that first one, this definitely looks weaker than that first one, but it definitely looks positive and somewhat of a line. Notice that the R value is on the lower side, so we would say weak positive. For the second row, middle one, we say a very low correlation coefficient, and I don't really see much of an association, so we would say no association. And the last one, not as strong as the one above it, but definitely forming a line in the negative direction, and so we say that that's moderately strong negative. So take a good look at this and let's respond to this question. What do you notice about the relationship between the description of the scatter plot and the value of the correlation coefficient? So there are 2 items that you should be looking at. So put the video on hold and see if you can find some sort of pattern going on here. Okay, we're back. Okay, so I noticed that when the correlation coefficient is positive, so on this first one and on this one, even a little bit on this one, though it's really no association, when the correlation coefficient is positive, it looks like the scatter plot has a positive slope. When the correlation is negative in this top row middle and top row bottom and top row last column, and then the one underneath to the left, second row all the way to the right, all have a negative correlation coefficient and a negative slope. Okay, so we're going to reveal that and take a moment to record that in your notes. For the next thing that you should notice is that when the correlation coefficient is close to either 1 or -1, the relationship is very strong, and it's weaker if the correlation coefficient is less than 0.5 or greater than -0.5. And so that's another relationship. Let me just delete this. That you should notice. When the correlation coefficient, and we represent that with a lowercase r, not a capital R, but a lowercase r, is close to 1 or -1, you have a strong linear relationship. So here are some basic facts before we move on. The correlation coefficient measures the strength and direction of a linear relationship. And it's very important that you notice that it is a linear relationship. Okay, so correlation coefficient is really only with linear relationship. And some other characteristics, the correlation coefficient is always between -1 and 1. As you get closer to +1 or closer to -1, the relationship's stronger. When you get close to 0, it's a weak relationship. If the slope of the line is positive, then the correlation coefficient is positive, r is greater than 0. And if the slope of the line is negative, then the correlation coefficient is negative. The correlation coefficient of 0.8 is generally, anything 0.8 or better is considered very strong. And if it's less than 0.5, it would be considered weak. So I want you to put the video on hold, and I'd like you to try example 2A and B. Okay, we're back. So for part A, we see that the slope is positive. So the correlation coefficient is probably positive. And I would say it's moderate. I wouldn't say it's strong or very strong. And to me, it looks like a positive 0.71. Okay, I'm not quite sure what you get, but let's take a look. It's 0.551. So I overestimated the correlation coefficient. For B, this is extremely strong. It almost is perfect, but not perfect, and it has a negative slope. So this is a negative slope, and I would say it's very strong. So maybe it's negative 0.94. Let's see. So let's reveal what the answer is. And did you do better than me? I'm a little off my game today. Okay. So here's some sort of idea so you can get a better sense of what's strong and weak. So for this first one, this is perfect. Every single point on the line, it's going in the positive direction. So R is 1. This is still very, very strong, but not all the points are on it. So 0.91. This is weak, positive, 0.48. This is no correlation. Negative 0.48 would be considered weak, negative. Negative 0.9, very, very strong. And then here's perfect. So if you click on the link in Schoology, and I have it also in the actual document, but you can go to the link in the Schoology folder. There's a fun game that you can play, and it actually improves your ability to guess properly the correlation coefficient. So you press that link, and then we're going to guess positive direction. It's forming a line. Let's say it's 0.65, and then reveal the answer. And it was actually 0.5277, and it gives you the estimate. Let's try this again. So this is stronger, but still positive. I'm going to say 0.75. Oh, that does not look 0.79, so I wasn't that far off. And I underestimated it, so I have a negative error. But this is something fun for you to do and to increase your ability to guesstimate the correlation coefficient. Now, the correlation coefficient is a summary statistic, and years ago we would have to calculate it out using this formula. This formula is on your formula sheet, and sometimes it's helpful if you want to see variables that affect the correlation coefficient. But shortly, I'm going to show you how you can use technology to calculate it, and you really do need to practice it. So I just want you to notice something about this formula. What you're actually doing is, if you take a look at this portion of the formula, that's the z-score for the x-coordinate. Remember, you're looking at every point in your data is an xy, it's a point. So what you're doing is you're taking the z-score of your x-coordinate for each point and the z-score of your y-coordinate, and for that same point, you're going to multiply it together. And you're going to do that for every single point in your data set. You sum that up, and you're actually taking the average of it. I won't discuss with you now, but we divide it by n minus 1 as opposed to n, and that's basically since we have to use the sample mean as opposed to the population mean as the estimate. But I'll go more into that at another time. So now you do need to know how to calculate the correlation coefficient with technology. And so we're going to go through an example. If you don't have your Inspire calculator next to you, please put the video on hold and get it. Okay, so 9th grade students at Webb Schools go on a backpacking trip each fall. Before leaving, students in their backpacks are weighed. The data here are from one hiking group in recent years with weights in pounds. So the explanatory variable is body weight and the response variable is backpack weight. So can you go ahead and predict the backpack's weight that someone has based on their body weight? Okay, and part A says, using your graphing calculator, find the correlation coefficient of this data set. So the first thing you're going to do is go start a new document in your calculator. And just like in the first unit, you're going to use list and spreadsheets. So the first thing is body weight. You can't have a space, so I use the underscore. You could use X and Y. I'm just being fancy. And this is backpack weight. And you would enter the data. Just to save time for the purpose of this video, I'm just copying and pasting, but you won't be able to do that unless you have the digital version on your computer. But you should practice by hand. And now let's get the second column. So put the video on hold to make sure that you've entered all the data. Make sure you're out after you enter the last piece of data, that you're out of that cell, because otherwise it doesn't recognize it as a value and it will cause an error. Okay, once you enter the data, you're going to hit Control Dock. That's going to get you into the menu so you can add an additional page, and you're going to add a calculator page. Have you done that? If not, put the video on hold. You're then going to hit Menu. We're in the Statistics menu, so number 6, and we're doing a stat calculation. Now hold. You're not doing number 3. In Algebra 1 and Algebra 2, your teachers may have done that mx plus b, because that's what you're used to, but in college, they use number 4. And they use it because eventually you do a multilinear regression, at least if not this level, the next level. And so you need to be in A plus BX format. So option number 4. You're going to enter in, you can either type in X if you use X. I'm using the actual name of the variable, body weight. And for my Y, I'm entering the backpack weight. Make sure you're entering X and Y properly. You do not need the other categories. That's fancy, but we're not doing that yet. Okay. And there's a bunch of stuff. At some point, actually soon, we'll be discussing the A and the B. The y-intercept and B is the slope of the line. R squared is something we discuss later. That's the coefficient of determination. But right now, we're using 0.9458. So let me go back to the presentation. So, and you must use letters, like you have to represent with the letters. So lowercase r, make sure it's a lowercase r, is 0.9458. And you should carry it to several, at least 3, if not more. Do not carry it to the nearest hundredth, at least 3 or 4. And we can see the scatter plot that they made, and this kind of verifies it. Ignore that red dot for now. Okay. One of the hikers was accidentally excluded from the data set. His body weight is 187 pounds, and his backpack weight is 24 pounds. How will adding this point to the scatter plot affect the correlation coefficient? So that's where that red dot came from. So if you, it's not on your paper, so I'd like you to make it. So go to estimate where 187 is and 20 pounds is. Before we actually calculate the correlation coefficient, what do you think would happen? Put the video on hold and write down an answer of what you think would happen. Okay, so let's actually see what happens. So go back into your calculator and let's go into, if you hit your cursor to 1.1 and scroll down, and we're going to enter 187 and 20. Make sure you're out of the cell. Excellent. And now we're going to rerun that. And actually, I'm going to help you practice doing this. So hit Control Dock to add a page, add a calculator page, hit Menu, Statistics, so number 6, Calculations, number 1, one variable statistics. Actually, I'm wrong. Hold on. Menu 6. I was getting the standard deviation there. Stack calculations, and we actually want option number 4, the A plus BX one. We're going to hit body weight again for our X and backpack weight for our Y, and we hit OK. And look at this. The y-intercept changed, the slope of the line changed, the coefficient of determination. Again, these 3 things are going to be discussed in later lessons. But notice that now the correlation coefficient dropped down to 0.0776. So that's a significant decrease, right? And that was just from that outlier. Okay, so let me just get rid of this. So R was 0.0776. So it dropped down significantly with that outlier. Okay, so I want you to remove, well, let me read the question first. How does switching the X and Y variable affect the correlation coefficient? So do you think it's going to have an effect on it? Let's check it out. So let's go back into our data set, and what I was going to say before is I want you to remove the point we just added in. Did you remove it? So what the question is asking is what happens if we switched and say, can we predict someone's body weight from their backpack weight? So we're going to find out. So we're going to hit Control Page, and we're going to add a calculator in it, calculator page, and we're going to do Menu, Statistics, Stack Calculations, and now we're going to go into 4, and we're going to hit backpack weight now. We're switching our X and Y, and body weight. And let's see. Notice the correlation coefficient did not change. It stayed at 0.9458. Okay? The slope and the y-intercept changed, and we're going to again discuss that later on in the unit. But the correlation coefficient did not change. So let's go back to the document. The correlation coefficient stayed the same. Again, R was 0.9458. And part D, if the weights were in terms of kilograms instead of pounds, how would the correlation coefficient be affected? And there are about 2.2 kilograms for a pound, and I converted it. It's not going to be exact because when I converted the data, I had a round at some point, but you're going to see what happens. So let's see what happens if we change the units, okay? So I'm going to go back into my calculator, and what I did is I'm going to add in a spreadsheet. So I'm going to hit Control Page Spreadsheet, and you're going to add in a new spreadsheet, and I'm just going to call this X kilograms just to save time, and Y kilograms. And I'm going to go into my data because I saved it just to make the video go faster for you guys. And I do Control C. And let's do this here. Okay, so let's see what happens. I'm going to add Control Page and add a calculator page. Menu, Statistics, Stat Calculations, option number 4. And we're hitting X kilograms. And we're going to hit Y kilograms and OK. And notice, yeah, it looks like it changed, but that only has to do with rounding. In actuality, if I carried this out to many, many decimal places, the correlation coefficient would be the same. So why is this all meaningful? Let me get back to the presentation. Sorry about this. Okay, so the correlation coefficient is basically the same. Again, it's only slightly off because I had a rounds when I was doing the conversion. So these are the most important features that you really do need to know inside and out. The sign of the correlation coefficient, represented by lowercase r, gives the direction of the association, okay, whether it's positive, negative, or none. The correlation is always between -1 and 1 inclusive. It can equal -1, it can equal 1, but very rarely in real life does that happen. Interchanging X and Y, as we saw, does not affect R. R has no units. It's been standardized, okay? That's why when we changed from pounds to kilograms, it stayed the same. Again, the only reason why it changed was because I had to round. R measures a linear relationship only. That's important. R is non-resistant to outliers. So non-resistant means it's affected by outliers. Hold on. Affected by outliers. That's messy, sorry about that. And one other thing, high correlation does not imply causation. So just because you take two sets of data and said, oh, the amount of ice cream you eat is linked to the number of drownings, just because you may show a high correlation may have nothing to do with the relationship. We can't say that the correlation, that the X variable caused the Y variable to happen. In fact, the only way we can establish causation is through a well-designed experiment. So please make sure that you have practiced using the calculator. My expectation is that even if you're not in class today, you have practiced it and you're thoroughly comfortable with using the graphing calculator to calculate the correlation coefficient and what we're going to do later in the unit. For homework, not only do you have to upload your notes, but you should be uploading 3.02 as well, just the free response. The multiple choice will be for the next homework assignment. Have a great day, and I will see you tomorrow.